6.5, solve problems using quadratic equations. So we're going to do applications now. So example 1, a ball is thrown up into the air. Its height in meters after t seconds is modeled by this equation here. Okay, so a little hint, as soon as there are decimals in an equation, most times I don't even waste my time trying to factor it. I just know that it's going to turn out not as pretty as the other ones, so I just use quadratic formula. Okay, so for what length of time is the ball above 50 meters? Okay, so length of time, we're looking for the t, and then we're given h. So let's go ahead for number 1, and let's sub in 50 for h, and we'll just write out negative 4.9 squared plus 38t plus 1.75. Okay, so we can't solve like this. We have to bring the 50 over and equate this to 0. Okay, so we get negative 4.9 t squared plus 38 t, and then we get 1.75 minus 50, we get negative 48.25. Okay, so I'm going to go ahead and factor this using quadratic formula. We know that this ball is going to be released and it's going to hit the ground here, right? So we want to know what length of time is it above 50. Let's just say that we need to solve for these 2 points that are above 50, and then we need to find the difference between these 2 times. Okay, so let's say A is negative 4.9, B is 38, and C is negative 48.25. Okay, so X equals negative B plus minus B squared minus 4AC, okay, all over 2A, so negative 4.9. Okay, so I'm going to go ahead and I'm going to put this entire expression into my calculator. So 38 squared minus 4 times negative 4.9 times negative 48.25. I get 498.3. Okay, and then this is over 9.8, negative 9.8. Okay, so this is where we can go ahead and we can branch off, and I'm just going to branch off up here so I have some room to write it. So we're going to get x equals negative 38 plus, well, if we rooted this, we could also do it this way, 22.3 over negative 9.8, and then we're going to go x equals negative 38 minus 22.3 over negative 9.8. So if we sub this into our calculators, we are going to get, for the first one, we're going to get 1.6, and then the double negative, we're going to get 6 point, let's round to 6.2. Okay, so we know, like on our diagram up here, this is going to be 1.6, this is going to be 6.2. Okay, we're going to have to subtract these. So 6.2 minus 1.6, we're going to get 4.6. Okay, so therefore the ball is above 50 meters for 4.6 seconds, right? It's this duration of time. Okay, now we're on to B. So when does the ball strike the ground? So this one's kind of just a straightforward question. Launch from here, strikes the ground here. This is just solving for the x-intercept. Okay, so let's go ahead and sub in h equals 0. And that way we can just go ahead and use quadratic formula and factor. Okay, so we have x equals, and remember this is a, b, and c. This time our c is 1.75. So b squared, no, negative b plus minus There we go. B squared minus 4AC all over 2A. Okay, so let's go ahead and put this in our calculators. 38 squared minus 4 times negative 4.9 times 1.75. I get 1478 decimal 3, and that's over negative 9.8. Okay, so we can go ahead and branch off. I'll branch off up here. So x equals negative 38 plus, and then we're going to have x equals negative 38 minus. Okay, I'm going to go ahead and root the 1,478 decimal 3, and I get 38.4. Okay, so when I put this one into my calculator, what I get is negative 0.04. And then when we put the double negative, what we get is x equals 7.80. Okay, so this side is not going to exist, that negative 0.04, but 7.8 is going to exist. So we can say, therefore, the ball hits the ground after 7.8 seconds. Okay, example 2. A uniform border on a frame photograph has the same area as the photograph. So we're going to have a photograph, and there's going to be a border. Very similar to like that matte frame. Okay, and the area of here, the photograph, is going to actually equal the area of the border. What are the outside dimensions of the border if the dimensions of the photograph are 25 by 20? Okay, so let's go 25 by 20. And then we're going to have x here and x here because it's uniform width, x here and x here. So let's go let x represent the width of the border. I always fill it with an A. Okay, so our new length is 25 plus 2x. Our new width is 20 plus 2x. So here's the thing. The area of just the mat, we have to find an expression where it's the area of just the, not the mat, the border. So this is going to be the area of the entire thing, which is 20 plus 2x, and 25 plus 2x, and then subtract the area of the inside, which is 25 times 20. Okay, and then this is actually going to equal that 25 times 20 because they're going to have the same area. Okay, so let's go ahead and expand and simplify this. So 25 times 20 is 500 equals, this is going to be 500 plus 40x plus 50x plus 4x squared minus 500. Okay, so these two 500s cancel out. We're going to bring this 500 over, and let's go ahead and put this in order. So I get 4x squared, I get 90x, and then I get negative 500. Okay, so we could first factor out a 4 here if we'd like. So we'd get x squared plus we can factor out a 2. Okay, so common factor just to get this expression a little bit smaller. But you know what? We don't even need to. If we're using quadratic formula, I say just plug these in because it gives us the zeros. It doesn't give us the factors. We're not actually looking for factors. So it doesn't matter if we use like 490, 500, or if we use 245, 250. Okay, it's going to give us the same factors. So let's go x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, so if we put this into our calculators, we're going to have 90 squared minus 4 times 4 times negative 500. Okay, this double negative here when we multiply this negative 4 and negative 500, it's key to give us this positive number in here. So just watch your number signs. Okay, and if we were to root this 16,100, what we're going to get is we're going to get x equals, let's see if I go down more. Yeah, I'll do one more line here. Okay, we're going to get x equals negative 90 plus minus 126.89 all over 8. So now let's branch off. Negative 90 plus 126.89 over 8, and then negative 90 minus 126.89 over 8. So when we put that into our calculators, we get 4.6, like 1125, so that's fine, and negative 2.7. Okay, so we're thinking about the dimensions and like the width of something, we are going to take on the positive value. Okay, so this one's inadmissible. We're going to take on the positive number. So that looks good. Therefore, let's go back up to the question. It asks, what are the outside dimensions of the border? Okay, so we know that the width is going to be 4.6. So the width of the border is 4.6. And if you wanted the actual dimensions, we'd go 20 plus 2x, and then 25 plus 2x. So the dimensions of like the whole photograph plus the border altogether. So 29.2 and 34.2. 29.2 centimeters, 34.2 centimeters. And that's going to be the length and the width. Okay, example 3. Tickets to a school dance cost $4 and its projected attendance is 300 persons. Okay, for every 10 cents increase, so this is plus and this is 0.10, in ticket price, the dance committee projects the attendance will decrease by 5. What ticket price will generate this much revenue? So we know that this is going to be a revenue question. So X is going to represent the number of price increases. Okay, and then R is going to represent the revenue of the school dance. Okay, so let's create our equation first. R equals, we're going to put the number in the first bracket. So first 300 people will attend, and then it's going to go down by 5 people for every price increase. Okay, and now we're going to do price. So it's $4, but it's going to increase by 10 cents, X number of times. So this is our revenue equation. Now this was a little bit different because they give us a revenue of $10.45. So let's go ahead and sub that in. Let's expand everything, and we'll bring over the $10.45. So 300 times 4 is 1,200. 300 times decimal 10 is 30. So it's plus 30x. Okay, Negative 5 times 4 is negative 20x. And then negative 5 times decimal 1 is going to be negative 0.5x squared. Let's bring this 1045 over. And while we bring it over, I'm going to put these in order. Negative 0.5x squared. Let's collect these two terms in the middle, so plus 10x. And then we're going to have 1200 minus 1045. So I get 155. So minus plus 155. Okay, so this has a decimal in it. I'm not even going to fight it. I'm just going to go ahead and do quadratic formula. So x equals, this is going to be our a, our b, and our c. So negative b plus minus the square root of b squared minus 4ac all over 2a. So let's go ahead and put that root in our calculators. 10 squared minus 4 times negative 0.5 times 155, I get 410. Over 2 times a half is going to be 1, so over negative 1. Okay, so x equals negative 10 plus minus, I'm going to actually go ahead and root this, 20.2 all over negative 1. Okay, so let's actually branch off. We have x equals negative 10 plus 20.2 over negative 1, and then we're going to have negative 10 minus 20.2 over negative 1. So when I put these into my calculator, for the first one I get negative 10.2, and for the second one I get 30.2. Okay, so because we're doing a price increase, I'm going to ignore the negative one. So I'm going to call this inadmissible. Okay, so there's going to be 30.2 price increases. If we go up to the original question, this is what ticket price will generate this. Okay, so this question is not asking for revenue and it's not asking for the number of people who will attend. It's only asking for this ticket price right here. So let's take that ticket price, 4 plus 0.10, and let's multiply this by 30.2. 4 plus 0.10. Okay, so they're going to have 30 and a bit 10-cent increases. So their new fare is going to be $7.02. Therefore, new fare is $7.02.